Welcome dear student and Jai Swaminarayan. In the first two lecture of this chapter, we will discuss about what do you mean by the sound, what are the characteristics of the sound. The characteristics of the sound are measured with the help of the different physical quantities like a frequency of the sound, time period of the sound, amplitude of the sound, speed of the sound, loudness and the pitch of the sound. The speed of the sound is different in the different medium. Now dear student, like the light wave, the sound wave are reflected from the solid surface and the liquid surface. So in this video, we will discuss about a reflection of the sound wave. First of all, what do you mean by the reflection? Reflection means bouncing back of a wave from the any surface. The surface may be a solid surface, the surface may be a liquid surface. The bouncing back of the any wave from the surface is called the reflection. In this video, we will discuss about the reflection of the sound wave. Like a light wave are reflected from the solid surface, right? The sound wave are also reflected from the solid surface. So reflection of the sound, like the light, sound get reflected at the surface of the solid or a liquid and follows the laws of the reflection. Dear student, we know that what do you mean by the reflection and the laws of the reflection? What do you mean by the reflection? When the wave are incident on the any surface, the bouncing back of the wave is called the reflection and it obeys the law of the reflection. So what are the laws of the reflection? First law of the reflection is the angle of incident is equal to the angle of reflection. So what do you mean by the angle of incident? The sound wave makes a angle with the normal to the surface is called the angle of incident. And what do you mean by the angle of reflection? The reflected wave makes the angle with the normal is called the angle of reflection. Understand? What do you mean by the angle of incident? Incident wave makes the angle with the normal to the surface is called the angle of incident, and reflect angle of reflection, reflected ray makes the angle with the normal is called the angle of reflection, right? So let us see this. So here let us consider this ray is a angle of incident ray, and this incident ray makes the angle, incident wave makes the angle with the normal is called the angle of incident, and it is represented by I. This ray is a reflected ray from this plane surface, right? So reflected wave makes the angle with the normal is called the angle of refraction, and it is represented by small I. Understand? So here, according to the first law of reflection, the angle of incident and angle of reflection are same. The angle of incident and the angle of reflection are same. Now what is the second law of reflection? The incident ray, the reflected ray and normal at the point of the incident all lies in the same plane. The incident wave, reflected wave and normal to the surface all are lies in a same plane, right? So how the sound wave are reflected? Let us take the activity. Take two pipes of the same length and arrange them on a table near a wall or a metal plate, right? So consider this type of the metal plate, right? Take two pipes, two hollow pipes of the same length, same diameter and arrange them, two hollow pipes near to this type of the plate or the near to the wall, right? Now clip a clock near the open end of the one pipe and try to hear the sound of the clock through the other pipe by adjusting the position of the pipe, right? So take the position of the first pipe like this, and on the open end of this pipe make a alarm clock, right? And by adjusting this pipe on the different angle, try to hear the sound of the clock through the open end of the other pipe. Now, at the one angle, you will hear the sound of the alarm clock, right? And this angle is same as the angle of incident. So now measure the angle of incident and the angle of reflection. So measure this angle and measure this angle. Now measure the angle of incident and the angle of reflection. You will find the angle of incident and the angle of reflection are almost same, right? Now lift the second pipe and try to hear the sound. So now lift the second pipe upward direction, other than the angle of incident, and try to hear the sound. You will not able to hear the sound. Why? Because here if the angle of incident and the angle of reflection are same, we can hear the sound, and for the other angle of reflection we cannot hear the sound. So it will gives us the conclusion like this, right? The angle of incident is equal to the angle of reflection, right? And the incident ray, reflected ray and normal all are lies in the same plane. So these two are the laws of the reflection. So the question may be asked in your examination like this: explain the laws of reflection with the help of the activity. So you have to explain this activity with the figure, right? Now two types of the reflection occurs in the sound wave. First one is the echo and the second one is the reverberation, right? So reverberation is what is the reverberation and what is the echo. So first we will discuss about the echoes, right? If we shout or clap near a reflecting surface like a tall building or a mountain, we hear the same sound again. This sound which we hear is called the echo. Now if we shout or clap near the reflecting surface like near the tall building, near the mountain, near the hills, we can hear the same sound again and again. And this sound is a echoes, reflection of the your sound. You will hear the reflection of the your sound, and this sound which we hear after some times is called the echo, right? So why the echo is caused, right? So if we shout or clap near the reflecting surface, near the tall building, mountain or a hill, right? The sound wave is traveling through the air and it will reflected from the hill or mountain, and we will hear the reflected sound, right? So this reflected sound is called the echo, right? So the echoes is caused due to the reflection of the sound. Now, in each and every case, we cannot hear the echoes of your sound. If you sit in your room, right, and if you shout or clap in your room, you cannot hear the echoes, right? Why? To hear the echoes clearly, the time interval between the original sound and the echoes must be at least 0.1 second, right? So to clearly hear echoes, right, the time interval between the original sound and the reflected sound, or the original sound and the echoes, must be at least 0.1 second. So if you consider the 0.1 second, it is a very small, right? The time interval between the original sound and the reflected sound, that is the echoes, must be at least 0.1 second minimum. But if we consider the speed of the sound wave in air, right? What is the speed of the sound wave in air? Approximately 344 meter per second. That means the sound is travel a 344 meter distance in a 1 second, right? So the distance traveled by the sound in a 0.1 second is a 344 meter per second speed into time 0.1, that is a 34.4 meter. So the speed of the sound wave is a 344 meter per second. So the sound travels a 344 meter distance in a 1 second, right? So the distance traveled by the sound in a 0.1 second, that is a 344 multiplied by 0.1, that is a 34.4 meter, right? So to hear an echo clearly, the minimum distance of the reflecting surface should be a half of this distance. So half of this distance is a 17.2 meter. So if the minimum distance between the origination of the sound wave and the reflecting surface should be a 17.2 meter, then and then you can clearly hear the echoes, right? Next one is the reverberation. Reverberation, that means the if the sound are reflected, multiple reflection occurs in the sound, the echoes we can hear a multiple times, and this is called the reverberation. So if the echoes may be heard more than once due to the repeated or multiple reflection of the sound from the several reflecting surface, this causes a persistence of the sound called the reverberation. So if the sound wave are reflected from the multiple reflecting surface, the echoes may be heard more than once, right? And this phenomena is called the reverberation. So in a big hall or auditorium, to reduce the reverberation, the roofs and the walls are covered by the sound absorbing materials like a compressed fiberboard, rough plaster or draperies, right? So reverberation can be here in a big wall, if in a big hall, right? So if you speak in a big hall, you can heard a multiple reflection of the sound, more than one, right? So that is called the reverberation. And to reduce the reverberation in the big hall or auditorium, the roofs and the walls of the hall are covered by the sound absorbing material like a compressed fiberboard, rough plaster. We can reduce the reverberation. So these two are the phenomena of the reflection of the sound wave, echoes and the reverberation. Now, to use of the multiple reflection of the sound wave, right? So when the sound wave are reflected multiple times, so what are the use of the multiple reflection of the sound wave? So first one is the megaphones, horns, musical instruments like a trumpet, serenade are designed to send a sound by the multiple reflection in a particular direction without spreading in all directions. So these musical instruments are designed so that the sound wave are from a sound wave are produced by the multiple reflection in the particular direction without spreading in all the directions. So this type of the megaphone, horns, musical instruments like a trumpet, serenade, right? All other musical instruments are designed so that the sound to send a sound by a multiple reflection, right? Second one is the doctors listen to the sound from the human body through a stethoscope, right? We know the stethoscope. Doctor use this type of the stethoscope, and the stethoscope is used to listen the sound from the human body, the sound of the heartbeat, reach the doctor's ear by the multiple reflection, right? Third is the generally the ceilings of the cinema hall and auditorium are curved so that the sound after multiple reflection reach all the parts of the hall. Sometimes a curved sound board is placed behind the stage so that the sound after the multiple reflection spread evenly across the hall. So the curved surface of the cinema hall, curved surface of the auditorium, right, is designed. The surface of the cinema hall and the auditorium is designed curved. Why? Because of the multiple reflection of the sound. So due to the multiple reflection of the sound are cover the so much part, whole the parts of the hall, right? So due to the curved surface, right, the multiple reflection of the sound spread across the hall, right? So these are the some use of the multiple sound reflection. So understand, dear student, reflection of the sound, echoes, reverberation, and use of the multiple reflection of the sound. Now, range of hearing. Human beings cannot hear the all the sound frequencies, right? Human beings can hear the sound frequencies between a 20 hertz and 2000 hertz, right? So human ears can hear the sound of the frequencies between the 20 hertz to the 2000 hertz frequency. So the sound wave which has a frequency in between 20 hertz to the 2000 hertz we can hear. Other sound waves we cannot hear. So this frequency is called the audible frequency. So the audible frequency for the human beings is a 20 hertz to the 2000 hertz, and so this sound is called the audible sound. This sound can hear by the human beings, right? Now the human beings cannot hear the sound which has a frequency less than 20 hertz or greater than 2000 hertz, right? So the sound which has a frequency less than 20 hertz is called the infrasonic sound, right? Animals like a dog, elephant, rhinoceros, whale, some animals produce and hear the infrasonic sound. So what do you mean by the infrasonic sound? The sound which has a frequency less than 20 hertz. Human beings cannot hear this type of the frequency, but the sound wave which has a frequency less than 20 hertz is called the infrasonic sound. Some animals like a dog and elephant produce and hear the infrasonic sound. Next one is the sound which has a frequency more than 2000 hertz is called the ultrasonic sounds. Animals like a dolphins, bat, rats, right, porpoise, right, produce and hear the ultrasonic sound. So ultrasonic sound has a higher frequency. The frequency of the ultrasonic sound is greater than 2000 hertz, and frequency of the infrasonic sound is a less than 20 hertz. So these two sounds, infrasonic sound and ultrasonic sound, cannot hear by the human beings, but some animals can produce and hear the infrasonic sound and the ultrasonic sound, right? Understand? The human being can hear the sound which has a frequency lies between the 20 hertz to the 2000 hertz, right? Not less than 20 hertz and more than 2000 hertz human beings cannot hear, right? The sound which has a frequency less than 20 hertz is called the infrasonic sound, right? And the sound which has a frequency more than 2000 hertz is called the ultrasonic sound, right? Some animals like a dog, elephants can produce and hear a infrasonic sound. Some animals like a dolphins, bat produce and hear the ultrasonic sound. The bat use the reflection of the ultrasonic sound waves to detect an obstacle or its prey, right? So bat produce the ultrasonic sound, and it used the reflection of the ultrasonic sound wave to detect the obstacle which is near to the bat, right? So understand. So first range of the sound is the audible sound. Audible sound lies between a 20 hertz to the 2000 hertz, right, which can hear by the human being. Second is the infrasonic sound. The frequency of the infrasonic sound is the less than 20 hertz. And third one is the ultrasonic sound. The frequency of the ultrasonic sound is a greater than 2000 hertz, right? Now let us see what is the use of the ultrasonic sound. Use of the ultrasonic sound. The ultrasonic sound is used to clean the objects like electronics component. The components to be cleaned are kept in a cleaning solution, and ultrasonic waves are sent into the solution. Due to the high frequency, the dirt particles get detached from the component. So first use of the ultrasonic sound is a ultrasonic sound is used to clean the objects like a electronic component. The components to be cleaned are kept in the cleaning solution, and ultrasonic waves are sent into the solution. Due to the high frequency of the ultrasonic sound, the dirt particles get detached from the component. Second, the ultrasonic sound is used to detect the cracks in the metal blocks. Ultrasonic waves are sent through the metal blocks, and if there are cracks, the waves are reflected back and the cracks can be detected. So ultrasonic sound is used to detect the cracks in the metal block, right? Third, third point, use of the ultrasonic sound is used in the ultrasound scanner for getting the image of the internal organ of the human body. So ultrasonic sound is used to get the image of the internal organ of the human body, right? It is used as a ultrasound scanner, and ultrasound scanner is used to get a image of the internal organ of our body, right? And last use of the ultrasonic sound is a ultrasonic sound is used to break small stone formed in the kidneys into the fine grains so that they are removed through the urine, right? So ultrasonic sound is used to break a small stone in our kidney or in our human body, right, into the fine grains so that it can be removed through the urine. So these are the some use of the ultrasonic sound wave. So ultrasonic sound wave is also used to measure the distance between the two submarines, right, in the sea, right? Ultrasonic sound is used to measure the distance between the submarines, right? So in the submarines also the ultrasonic sound wave is produced. In the sonar system also the ultrasonic sound wave is used. That we will discuss in the next video. So sonar we will discuss in the next video, right? Thank you very much for watching my video.